Science Centre. Are you having a good day today? Yeah! Wow, I don't have to ask you a second time. So glad of that. Well, my name's Charles, and we're going to do our next Science Live experiment here. And what we're going to talk about this time is something that's been in the news quite a lot over the last year, and that's rockets and rocket ships. Who likes rockets here? Oh, lots of hands going up everywhere. Well, we all know when rockets go up in the air, they do make a lot of noise, but that's because they have to lift a huge load up into the air and defy gravity. Now, who knows what gravity is around here? Yeah, lots of hands going up. What do you think it is? Is it, if I were to jump in the air, do you think I would come back down again? Yeah. Yeah? Do you all agree with that? Yeah. Yeah. So it's a big force to have to overcome. So when rockets take off, they have to generate a lot of force to go up there. Now, there was an engineer called Sir Isaac Newton. He was even older than me. And he said in his third law of motion, for every action, there's an equal and opposite action. And we can demonstrate this. Who has a scooter here, or a skateboard? Or seen anyone use a scooter or a skateboard? Yeah? Okay. You all have. There are lots of hands going up. So you'll know, if I'm on my scooter and I want to go forward in this direction, which way must I push with my leg? Backwards. Do you agree with that? If I'm going to go that way, I have to push my force that way, behind me. Yep. Lots of nodding going on. I'm glad to see that. So, if the rocket goes up in the air, which way must the force go? The rocket goes up, the force goes down. Absolutely right. Well, as you can imagine, we can't have a real live rocket here in the Science Centre because after it took off, we wouldn't have a lot of Science Centre left. But what we can do is demonstrate that on a much, much smaller scale. Now, the way rockets actually generate all of that thrust is a very simple principle based on the fire triangle. That is, you have a fuel, an oxidizer, and heat. They're the three things you need for combustion or to make fire. And rockets actually have this. Now, when rockets, if you listen to a countdown at a launch, there's a very, very important word that they put in there before the rocket finally takes off. They're 5, 4, 3, 2, 1. And then you hear that word. Ignition and liftoff. Who's aware of that? Yeah? Lots of hands going up. That's an important word. And do you know, it's a bit like my gas lighter. When they say ignition, they literally do that underneath the rocket and ignite the fuel and oxidizer. So when you watch a rocket launch next time and they get close to liftoff, you'll see underneath, when they have those lovely pictures, you'll see all the fuel and oxidizer coming pouring out of the engines underneath, and then they say ignition and the whole thing goes on fire and liftoff because you've generated that thrust. And you know, we can do that in miniature with our little tiny rocket. Now, what I've got in here is methylated spirits. Now, it's not a separate tank for its oxidizer, but what we can do is mix it with the air in the bottle. And by mixing it with the air in the bottle, we should end up with a fuel and oxygen mixture. And we can do those very important things and see if we can now make our bottle pretend it's a rocket and go across the room. Would you like to see that, everyone? I thought you would. So, what I'm going to do, oops, I've locked myself out, is just go back into my cupboard here, fetch my beaker, because we don't want it to knock a hole in the wall, so I have to empty some of this out. So what we're going to do is to pour out the excess of the methylated spirits, and what we should be left with in the bottle is a mix now of the vapor of the methylated spirits and the air. So we've effectively got my rocket fuel and oxidizer, and all we need now is ignition. So let's see if this works, guys. Just like a real launch, we'll go 5, 4, 3, 2, 1, ignition. And there you have it. That's how a rocket works, everyone. My name's Charles. We did some more.